Well, you finished? Keep going, come on, we got 15 minutes.
To learn about mountains and what they're made of, the more fascinating this question becomes. Most mountains are forming today in tectonically active regions, where the movements of plates deform the rocks of the Earth's lithosphere. The tremendous energy that's expended in the mountain building process often has a profound effect on these rocks. The geologic events that accompany mountain building, such as the collisions between plates, deep subsidence of ocean crust, moving masses of magma, and the displacement of rock bodies along fault zones, all the heat and pressure of the rock. As a result, these rocks are changed dramatically. This process of change, by the effect of heat and pressure, is called metamorphism. A term derived from the Greek words meta, which means change, and morph, meaning form. Metamorphism is the appearance of rocks, their mineral composition, and even their age, as measured by radiometric. During metamorphism, bodies within the rock can dislodge themselves from mineral lattices that move out. This atomic reshuffling causes the existing minerals to crystallize and new minerals to form. This process also resets the radioactive clock within the rock at the time of metamorphism. Metamorphism can result in complex structures and rare minerals that make these some of the most bizarre-looking and strikingly beautiful of all crustal rocks. But for geologists, the real beauty of metamorphic rocks is the information they contain about tectonic processes and Earth history.
The finish here is hide now.
Metamorphic rocks can appear in many forms. From flaky, black, fine-grained stone, to granite-like layered rock, to the marble used by sculptors. One explanation why a wide variety of metamorphic rocks exists is simply that there are many different sedimentary and igneous rocks, each responding to metamorphic conditions in its own unique way. Geologists use the term protolith to refer to the original rock existing before metamorphism. For example, limestone is the protolith of marble, one of the most common metamorphic rocks. And basalt, a volcanic igneous rock, is the protolith of amphibole. But geologists have found many more types of metamorphic rocks than protoliths. So factors other than original composition must also play a role in creating these rocks. Study of geologic structures such as folds and faults suggests that there is a wide range of pressures and temperatures inside growing mountain belts. Quite likely, this plays a critical role in explaining variations in metamorphic rocks. Laboratory experiments have helped geologists understand metamorphic conditions.
The conditions under which metamorphism occurs is beneath the level of weathering and sedimentation to form the sedimentary rocks, generally at temperatures of a greater than 200 degrees, and at conditions that do not produce a melt such as goes into igneous rocks. So the range of temperatures are roughly about 200 degrees to about 800 degrees. The process and the formation of the rocks occur at depth, generally from 2 to several tens of kilometers in depth beneath the Earth's surface.
At the surface, we are accustomed to the pressure of the air surrounding us. We don't notice the air because the pressure is equal all over our bodies. Deep underground, however, the pressure is not equally applied. Rock can be squeezed strongly with pressure greatest in the direction of the squeezing. Sometimes, Opposing pressure can be applied on different parts of a rock, causing it to bend or shear apart like a sliding deck of cards. Whether from shearing or simple squeezing, the rock is experiencing what geologists refer to as directed pressure or directed stress. The structure of many metamorphic rocks is a result of directed pressure. Directed shear stress, for example, helps explain the origin of a spectacular form of crystal growth. These swirling images suggest several things: a cluster of spiral galaxies, the Chinese symbol for yin and yang. They are, in fact, snowball garnets. To the geologist, frozen slices of metamorphism in action. The swirling pattern in a snowball garnet is formed by planes of tiny mineral inclusions that are swallowed up by the garnet as it grows. Shear stress causes the garnet to rotate during growth, distorting the planes into swirls. The three-dimensional form of the swirling pattern can be shown by means of a multi-ring model. Each ring represents the edge of a plane of minerals incorporated by the growing garnet.
These are the rings. And let's do that process as it goes on so we can visualize it. First we grow a little bit of garnet, then we rotate the ring, we rotate that and grow another ring, and rotate it with the ring inside, and we grow another ring and so forth until we develop basically a shape like this, in which we have a little pit over here, a little mound over here, and the diameter of the rotation here. We can compare that with a real specimen, which is over here, and this is a real specimen in which we see a little pit here, a little mound here, the common axis through here, and it shows a snowball pattern. In the same specimen, we can see a cross-section of a garnet that's growing considerably more than that garnet is, showing that rotation.
Directed stress involving compression helps explain the origin of a very common metamorphic structure. As temperature and pressure increase, minerals recombine to make new, more stable minerals. The minerals grow in the directions of lowest pressure, perpendicular to directed stress. This results in a layering, which geologists call foliation. Shear stress, too, can cause foliation.
I'll hold a piece of a metamorphic rock we call a schist, a mica schist, and we can see it's very layered. That layering is a preservation of a stress field generated within a subduction zone as the rock is recrystallized under great pressure and great temperature. And it's also recording the intensity of the stress field. Because he stresses that
Oh my. Yeah.
That's the old Mario, isn't it?
Foliated rocks
So that's the old one. This is the newer one.
Yeah.
often taken for granted at
tell.
some cost.
Yeah. What time? 22?
Those games.
Constructing roads, dams, or foundations on such rocks can
Not
create
much time
severe
left.
problems.
The production of foliation in metamorphic rocks
I'll try.
rise to the same type of structural and weak directions as defined in landslide progress and sedimentary rocks. So although we consider these basement rocks to be quite stable, in reality schist can be fairly unstable. Any engineering firms that would want to construct either houses or dams or other types of construction on metamorphic rock has to take into consideration the foliation and the direction of the foliation to make sure that it isn't an unstable orientation with regards to the engineering works that are constructed on it.
In addition to directed stress, rising temperature will cause minerals in a metamorphic rock to react, forming new crystal lattices and mineral types. This process, called recrystallization, generally causes minerals to grow larger, developing an interlocking texture resembling that of the mineral's prize. For example, when the sedimentary rock limestone is metamorphosed by heat into marble, the fine grains of calcite in the original limestone recrystallize into large calcite crystals, which interlock to give the emerging marble a coarse texture. In some circumstances, the temperature of a deeply buried rock becomes so great, the rock starts melting. When this happens, a rock having both igneous and metamorphic features results. Geologists call these intermediate rock types pegmatites, or mixed rocks. In some pegmatites, geologists find evidence for the origin of one of Earth's most common igneous rocks, granite. Yet another factor may be critical in creating metamorphic rocks.
24, I don't get
For
20.
many years, geologists believe that the overall composition of a rock rarely changes
So
during
Piper got like
metamorphism.
25, isn't it?
However,
Yeah.
this is no longer assumed to be the case.
You said that's a
The
switch.
other aspect
Internal
of
switch emulator.
metamorphism as a result of these
Like
metamorphic reactions is
play
that
the
the
games
rocks
like
undergo